All right, this video is going to go over how to solve exponential equations. It's not that difficult to do, so let's get started. Look at number one. The key to solving these is you want to get the same base. Like you want both to be 2 to the power of something. So if you look at 8, hopefully you'll realize it's 2 cubes. So this problem turns into 2 to the x equals 2 to the 3. And when you have the same base, you can just set the exponents equal to each other. So you can just go x equals 3. So like the next one, you would change 9 to be 3 squared. So x equals 2. So those are the easiest ones. Now look at 3. Change 125 to be 5 cubed. So you end up setting the exponents equal to each other and you get x squared equals 3. Well, then you would root it to get x equals, just don't forget your plus minus when you root something. So it's plus minus root 3. Which brings us to problems like number 6. Change 27 first. 27 is 3 cubed. So you have 3 to the x equals 1 over 3 cubed. All right, now that's not the same base. This is like a 1/3 base. You need it to be just 3. So the way you do this is you go 3 to the x equals, you bring that 3 cubed up to the top, and it becomes 3 to the negative 3. Whenever you switch places in a fraction, the exponent switches signs. So this one is x equals negative 3. So like number 8, you would change 9 to be 3 squared, and then you would change this 3 squared, bring it to the top, it would become 3 negative 2. So you get x equals negative 2. All right, now what if you can't make the same base, like number 9? You can't change 32 to be 4 to the something. It doesn't work like that. So what you do here is you kind of go smaller. So like 4 is 2 squared. So like this side turns into 2 to the 2x by the power to power rule. I'm multiplying that 2 to the x. Well, you just got to then get 32 in powers of 2. So this is 2 to the 5. So you end up with 2 to the 5 equals 2 to the 2x. And so you got 5 equals 2x, and then you can just divide by 2. X equals 5 halves. So that's how you handle those. So like number 11, you would change 128 to be 2 to the 7, and you would change 4 to the x to be 2 to the 2x. And so you got 7 equals 2x, and then you just divide by 2. X equals 7 halves. They can try to make it a little more complicated like that by doing something like, look at 19. You would have to change 9 to be 3 squared. And then you got a power to a power rule. So you're going to be multiplying like this 2x plus 1 times the 2. Well, you're going to have to distribute that. So this left side turns into 3 to the 4x plus 2. And then this 27, this is 3 cubed. Then you're going to be multiplying that because of power to power. So this side turns into 3 to the 3x plus 6. And so now you can just be like, okay, 4x plus 2 equals 3x plus 6. Get your x's on one side and your numbers on the other to get your answer. So I hope that's making sense so far. Now, something else that they will do is, look at number 17 here. First of all, get the bases the same. So you got 2 to the 3x minus 1. And then on this right side, this is 2 squared. So you got all of this is your power, and it's power to power, so you're multiplying. So it turns into 2 to the 2x squared. So you end up with 3x minus 1 equals 2x squared. When you have a quadratic that you're trying to solve, you need to make it equal to 0 first. So I'm just moving the 3x and the minus 1. And the reason you want it to equal 0 is because now you can solve it. I mean, factor it in order to solve it. So you factor it, and then you set each of these factors equal to 0. So if you have a quadratic, make it equal to 0 and try to factor it. Well, sometimes they will also throw you a curveball by giving you one that does not factor. Like look at number 28. All right, the first thing you're going to want to do is you're going to want to get the bases the same. So you need to get them both to be 3a. So like this right here, this is 3a cubed. So it's like 3a cubed to the x plus 6. So when you rewrite this, you'll have 3a to the x squared plus 4 equals 3a. Distribute that 3 to the x plus 6, so you get 3x plus 18. So now you can just go, okay, well, x squared plus 4 equals 3x plus 18. Get everything to one side, aka make it equal 0. So you get x squared minus 3x minus 14 equals to 0. Okay, well, this does not factor. So when it does not factor, you have to run your favorite thing in the world, quadratic formula. So you get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so now just plug it in. A is 1, b is negative 3, c is negative 14. Just watch your signs when you plug it in. So the negative b part just means change the sign of b. So you get x equals 3 plus minus the square root of negative 3 squared is 9 minus 4 times a times c over 2a, 2 times 1. All right, everybody always messes up. If you're going to mess this up, you're probably going to mess it up right here. This turns into 9 plus 56, which is 65. So your answer here is 3 plus minus root 65 over 2. Now, just one more thing before I let you go. Let's do a hypothetical. Imagine you did the quadratic formula there and you ended up with like 4 plus minus 2 root 10 over 4 or something. If all three of these numbers, not the root, just these lead coefficients, if all three of these can reduce with each other, then you have to reduce them. So this one, they're all divisible by 2. So you would get 2 plus minus 1 root 10 over 2. Now, had we done this and say it said something like 3 plus minus 2 root 10 over 4, well, these numbers do not reduce. So you would just leave this as is. So, all right, there's how to solve exponential equations. Just get the base the same and then set the exponents equal to each other and go solve it. Hope this video helped.